Hey everyone, welcome to NCX Maths, and in this video we're going to discuss on some basic concepts of point set topology. So in this video we're going to discuss on what is an open ball, and then interior points, exterior points, boundary points, and some of their examples. Okay, so first let's start with the open ball. So open ball is defined in this way. Let C be a real number and R be greater than 0. Then an open ball with center at C and radius R is denoted by BCR, and it is defined as BCR is equal to set of all real numbers x such that modulus of x minus C is less than R. Okay, so this means open ball with center C and radius R, it is denoted by this, as you can see here, and it is defined as set of all real numbers x such that modulus of x minus C is less than R. So this means it is set of all the real numbers x whose difference with C is less than R, since this modulus represents difference between these two quantities. So this means a ball with center C and radius R can be defined as set of all real numbers whose difference from C is less than R. So we can define this ball with center C and radius R in this way as well. Modulus of x minus C is less than R. So this means by using the property of modulus, we can write it as minus R is less than x minus C is less than R. Using the property of modulus, we can write this. And if we add C on all the sides, we get C minus R is less than x is less than C plus R. So this inequality also represents the same open ball, and we can show this in a real line in this way. So suppose if this is a C, suppose here we have C minus R, and suppose there we have C plus R. So this ball with center C and radius R denotes all the real numbers between C minus R and C plus R. Okay, so all these real numbers here. So all these real numbers between C minus R and C plus R represents the open ball with center C and radius R. So for example, suppose a ball with, let's say, center 5 and radius 1 by 2. So using the concept of this interval, we can say that this ball represents all the real numbers between C minus R and C plus R. So this means, so C minus R, this means 5 minus 1 by 2, which is 4.5, up to C plus R, which means 5 plus 1 by 2, which is 5.5. So in this way we can say that this ball represents a ball with the center at 5 and radius 1 by 2. So this is 5.1 by 2, which is 5.5, and 5 minus 1 by 2, which is 4.5. So all the real numbers between 4.5 and up to 5.5 represents this ball B 5, 1 by 2. So I hope this gives you a clear picture of an open ball. So this is in the case of a one-dimensional space where we consider a real line. So in the same way, in a two-dimensional space with ball with center C and radius R, so this represents a circle with center at C and whose radius is R, and all the points inside this circle represents this open ball BCR. And in case of a three-dimensional space, we can consider a sphere with center at C and radius R. So now we're going to discuss on interior point. So interior point is defined as, so here A is a subset of R and a point C belongs to R is an interior point of A if there exists R greater than 0, so that the ball with center C and with radius R lies entirely in the set A. So this means, suppose we have a set A which is subset of R, and then a point C is called an interior point if there exists a ball with center C and radius R which lies entirely in the set A. Let's say we have a set A is equal to let's say 1, 3. Okay, so this is a set 1, 3. We can represent this in a real line. So take a point, let's say 2, which belong to the set A. So this point 2 is an interior point of A because let's say 2 lies here. So this 2 is an interior point because for this 2 we can create a ball, okay, with radius greater than 0. Let's take R equal to 1 by 2, okay, 1 by 2. So if we take the radius 1 by 2, or let's say which is 0.5. So now the ball with the center 2 and radius 0.5 lies entirely in the set because, so this ball with center 2 and radius 0.5, so you know that this represents an interval with left end 2 minus 0.5 which is 1.5 and right end 2 plus 1.5 which is 2.5, you know. So this is the ball. So this represents the ball with center 2 and radius 0.5, and we can see that this point lies entirely in this interval 1, 3. So we can say that this point 2 is an interior point of this set A. So I hope this gives you a clear idea about an interior point. So we can say that all the points between 1 and 3 are its interior points, and the points 1 and 3, these are not the interior point of this set, and you can verify this yourself. So next we have interior point, and it is defined as, suppose we have a set A which is subset of R and this C belongs to R, or real number C is an exterior point if there exists R greater than 0, so that this ball with center C and radius R lies entirely in A complement. So this means we can consider an example like before. Suppose we have a set, let's say 1, 3, an interval 1, 3. So exterior point is the point, let's take a point, suppose 3.5, okay, 3.5. So this point 3.5 is an exterior point of this set A because, so for this point 3.5 we can take a radius R, let's say R is equal to 0.05, okay, was it greater than 0, so that the ball with center at 3.5 and radius 0.05. So this open ball can be represented as an open interval like before. So 3.5 minus 0.05, so which is 3.45. So but this is here 3.45 and 3.5 plus 0.05, so which is 3.55. Okay, So this is the open ball with center 3.5 and radius 0.05, and we can see that this ball lies entirely in the A complement, because here we have A, this is set A, and this is A complement which is outside of A. So we can see that this ball with center at 3.5 and radius 0.05 lies entirely in the A complement. So we can say that this point 3.5 is the exterior point of this set A. Okay. Next we are going to discuss on boundary point. So there we have again A, a subset of R, and a point C belongs to R, a real number C, is boundary point of A if for every R greater than 0, ball with center C and radius R intersection A is not an empty set. And also same goes for A complement, ball with center C and radius R, its intersection with A complement is also not an empty set. Such point C which satisfies these properties, both properties, is called a boundary point for the given set. So we can make it more clear with another example. Okay, so consider the same set 1, 3. A is equal to an open interval 1, 3. So here these points 1 and 3. So these are the boundary points of these sets, because we know that this is set A and outside of this we have A complement. So here also it's A complement. So for every ball that we create at this point 1, let's say ball with center 1 and radius 0.5. So this is an open interval with endpoints 0.5 to 0.15 to 1.5. So this represents the ball, and we can say that the intersection of this ball with the set A, it is not empty because this portion belongs to the intersection of the ball and A. So this is not empty, and also the intersection of this ball with A complement. So this is the portion, intersection portion, and this is also not empty. So we can say that this point A is a boundary point of set A. And also in the same way we can say that this point is also boundary points of set A, because so each and every ball with center C with center 3 and its intersection with this set A is not empty, and also its intersection with A complement is also not empty. So we can say that these points 1 and 3, these are the boundary points of this set A. So we can generalize this with an example. For an open interval A comma B, its interior point is all the points between A and B. So this means we can say that interior point of this open interval A comma B is the set itself and its exterior points. So we can see from the previous example that its exterior points are minus infinity to A to B to infinity, which is A complement, and its boundary points are A and B. Okay guys, so this was for today. So I hope it gives you a clear idea about open ball, interior point, exterior point and boundary points. And if you still have some confusions, please comment down below. And if you find this video useful, please like this video and do subscribe my channel and turn on notification for more higher mathematics related videos. Thanks for watching. Have a nice time.